The question says consider the following complex ion PQR. You can see these are the following complex given here, and it says that the correct order of complex ions according to their spin only magnetic moment values in Bohr magneton. Okay, we have to calculate spin only magnetic moment for these complexes, and then we have to arrange them in the orders. Always keep in mind spin only magnetic moment value depends on the number of unpaired electrons. Higher the number of unpaired electrons, higher is the magnetic moment value. How we determine? We have the formula. Mu is equal to under root n bracket n plus 2, and Bohr magneton is there, where n is the number of unpaired electrons. Unpaired electrons are there. Okay, as the n value increases, mu value also increases. Okay, so first we can calculate the number of unpaired electrons, and then we can arrange them in the order based on the value we obtain. Okay, and we use valence bond theory because it is related to finding the number of unpaired electrons. It will be quite easier, and the steps which we follow in valence bond theory. First step is what? Calculate oxidation number of the central metal atom. Next, we have electronic configuration of the central metal ion. Next, we have orbital notation. In orbital notation, before filling electrons, always consider the effect of ligand. Whether we have a strong field ligand or weak field ligand. A strong field ligand, pairing of electron, and weak field ligand, no pairing of electron. Okay, one by one. First one is there. We have, you can see Fe. Calculate oxidation number. We have Fe is there plus, this is what fluoride ions 6 minus 1 is there. Overall charge is what? Minus 3. Fe minus 6 is equal to minus 3 is there. Fe is present in plus 3 oxidation number. Okay, now we write electronic configuration. In case of Fe, atomic number 26, it is what? 3d6, and we have 4s2 is there. Fe, it is having plus 3 oxidation number, losing 3 electron, it is 3d5 is there. Okay, now we go for the orbital notation. 3d5 is there. Before filling electrons, consider the effect of ligand. You can see this is what? Halogens in general are weak field ligands, means no pairing of electrons, singly filled. Follow Hund's rule. 1, 2, 3, 4, 5. You can see it is having maximum number of unpaired electrons. I can write here, and value is 5. It has highest magnetic moment because d orbital can have a maximum only 5 unpaired electrons. Okay, now next we have vanadium. Okay, in case of vanadium also we can calculate. We have vanadium V, and it is H2O, a whole 6 is there, and power 2 is there. Calculate. So in this case, neutral ligand is there. Water molecule is a neutral ligand multiplied by 0. Overall charge is what? Plus 2. The vanadium is present in plus 2 oxidation numbers. In case of vanadium, what is the atomic number? 23. We have 3d3, and it is 4h2. Now vanadium is having plus 2 oxidation number. Then it is left with 3d3 is there. 3d3. Okay. Now we go for the orbital notation. 3d3 is there. Orbital notation 3d3, and you can see again, you consider the effect of ligand. It is a weak field ligand. Water molecule is a weak field ligand, means we have 1, 2, 3, no pairing of electron. In this case, you can see central metal atom is having how many number of unpaired electrons? It has 3 unpaired electrons. Okay, it has 3 unpaired electrons. Now last one is there. Okay, Fe, H2 whole 6, and power 2 is there. Power 2 plus is there. Let me write this complex. We follow the same steps. We have Fe, it is H2O, and then having 6, and this is what? Plus 2 is there. Okay, Fe, water molecule as a neutral ligand is equal to plus 2 is there. Fe is present in plus 2 oxidation number. For Fe, we have atomic number 26, 3d6, and it is 4h2 is there, and then Fe is having plus 2 oxidation number. Then we are getting 3d6 is there. Right, orbital notation for Fe2 plus. Orbital notation. We have 3d6. Water molecule is there as a weak field ligand, no pairing of electron, singly filled. 1, 2, 3, 4, 5, and it is 6 is there. In this case, how many unpaired electrons are there? You can see 4 are there, and value is 4. We got n value 4. You can see in each complex we are able to calculate the number of unpaired electrons, and now we can arrange them in the order. Higher the n value, higher is the magnetic moment. Okay, so you can see we have in the increasing order, the first we have Q. First we are getting Q, and after this we have R, and then we have highest P is there. QRP. Any such option QRP, you can see option A is correct. If you like this video, please share and subscribe to the channel.